Hello, everyone. We're going to be looking at how to analyze and interpret a graph so that you can use detailed answers to earn a level 4. So I'll give you, for two different graphs, an example of like a level 1 answer or, well below what we're looking for, and then an example of a level 4 answer, which has enough detail to earn a level 4. So we're going to see two bad examples and then two good examples of earning a 4. So this first graph, the title up here states, how fast can you run a mile in different shoes? The independent variable on the x-axis is the type of shoes. So the experimenter is putting people in different types of shoes on purpose. The dependent variable is their time, how long it takes them to run a mile. So how long it takes to run a mile depends on the type of shoe a person is wearing. So we have the independent variable, the type of shoes, and the dependent variable, the time in miles. And then if we look at the graph, running shoes has the shortest time, which means people ran the fastest in running shoes. Flip-flops have the highest time, the longest time, which means people ran the slowest. It's important to look at what the axes are because bigger is not always better. If you have more seconds, you ran for longer, which means you ran more slowly. So bigger is not always better. Flip-flops are not better for running than running shoes. So here's an example of level 1 responses to this question. For summarizing the data, you could say people wear different kinds of shoes. That's true. That's not wrong. You can look at this and say people wear different kinds of shoes, but that answer doesn't answer the question. This doesn't address how fast you can run in different types of shoes. This is just stating a fact. And you can find lots of facts in a graph, but we're looking for facts that help address the question, which is how fast you can run in different types of shoes. A second fact in here is that people have run a mile in flip-flops. That's in the data, but it doesn't address how fast you are in different types of shoes. So let's look instead at a level 4 response to this. After looking through the data on the graph, I learned that flip-flops are the slowest shoe to run a mile in, taking 450 seconds. I also learned that running shoes were the fastest to run in, taking only 380 seconds. So I want to point out a couple of things in this level 4 response that bring it to that level 4 data. If you were to just put, after looking at the graph or the data on the graph, I learned that flip-flops are the slowest shoe, that's probably around a 2 or a 3 in my opinion. The thing that takes this up is addressing the actual numbers in the data. You don't just say that they're the slowest. I went on and added how long it took to actually run a mile in flip-flops by saying 450 seconds. I also then, to really bump it up to a level 4, added a second fact. I also learned that running shoes were the fastest, and then again I addressed the data saying the time. So they ran it in 380 seconds on average. So by addressing the data, by putting 450 seconds and 380 seconds, I provided evidence for my claim. I claim that flip-flops are the slowest. The 450 seconds of time is evidence for that claim. I also claimed that running shoes were the fastest, and by saying it took 380 seconds in running shoes, that's evidence for that claim. So I talked about multiple pieces of evidence from the graph. I made a couple of claims about what I've learned, and I provided evidence to support those claims. So that is a level 4 answer. And you can see this answer is not overly long. It's 2 sentences, but those 2 sentences provide a lot of information. So here's a second graph that we can look at for like a level 1 response. The title of this graph is Differences in Body Temperature Throughout the Day for Iguanas and Humans. The red line is body temperature for humans. the blue line is body temperature in iguanas. And then you can see if you move across the x-axis, as you move towards the right, it's different times of day. That means the independent variable is the time of day, and the y-axis, the body temperature, is the dependent variable. The body temperature depends on the time of day that it is. So here's 2 level 1 answers. Humans are hotter. This doesn't even say humans are hotter than what. You could have at least, or an example could have at least said humans are hotter than iguanas. Or another level 1 answer is that iguana's line is wavy. That's true, but what does the waviness in that line represent? So the waviness represents that the body temperature is changing in the iguanas. And again, we want to make some sort of analysis on this. So here's a level 4. After looking at the graph, I noticed that throughout the day, humans' body temperature does not change very much, while the iguana tends to warm up and cool down. I think this is because human is warm-blooded and the iguana is cold-blooded. So I've addressed both the line about humans and the line about iguanas. I've related that I understand the change in the direction or the height of each line represents a change in body temperature. And then I provided a hypothesis or a potential reason for why the lines look different between humans and iguanas. So hopefully this will help you with the other 3 graphs that we're going to be looking at on the level of detail required to earn a 4 on this assignment. Thanks for watching.